Good morning, my name is Felipe Santos. I'm here to present the Laboratory of Robotics and IoT for Smart Precision Agriculture and Forestry, the Tribelab, from Inesc. Inesc is a private, non-profit R&D organization that makes a bridge between companies and universities. This helps to support the innovation from the companies through the knowledge that is developed and created at the universities. We help also to bring this challenge that are done or acquired from the companies, and we bring this challenge to the academia to tackle new problems. To take the knowledge to the market, we have several initiatives at Inestec that through the challenge that we have in the society, we driven our developments and research at Inestec. To do this, we have the initiatives that are tech for something, the tech for agro-food, for energy, for health, and for industry and for sea. At the domain of Tech for Agro-Food, where I belong to and I am the coordinator, we aim to co-shaping the digital revolution agro-food and forestry. The remain tech initiatives can be seen and more detailed in our website. To build and solutions for these sectors, we have at our institution 13 centers that are grouped in four main clusters. The cluster of network intelligence systems, power and energies, computer science, and industrial systems engineering. Well, Inestec is established in the main universities of north of Portugal. We are established in Porto University, on Polytechnical Porto School, also in University of Braga and University of Trás-Montiel de Douro, Utad. We have 6 sites where we have our office and laboratories, and we have 19 laboratories spread around the 6 sites and 3 cities. We have the same model replicated in Brazil that helps to support the innovation in the Brazil ecosystem. Besides of that, Inestec incorporates more than 1,000 of researchers from them 350 are fully integrated and PhD members at Inestec. We have more than 25 nationalities and 200 of people are going to the market that have passed from Inestec, mostly master students and PhD students. Inestec is the main associated institutions and owners of Inestec are Porto University, Polytechnical of Porto, Inesc Lisbon, Universidade do Minho, and Utad. We have also cooperations with big universities of the north of the United States, mostly UT Austin, Carnegie Mellon, and MIT. We have a good cooperation with big players in Portugal. Most of them you can see in this slide: IKEA, Siemens, Vestas, Bosch, but we have in all of domains of the ecosystems. We have a good internationalization belonging to the main associations and clusters around Europe to drive the innovation and promote our thinking. And we have also an active role on policy making, and also we are belonging and members of the main and relevant collab initiatives that are collaborative laboratories in Portugal. Well, speaking about Tech for Agro-Food, like I mentioned before, we have the motto of co-shaping the digital revolution in the agro-food and forestry systems. To do this at the moment, the most topics that we have at Inestec that are driving the technologies for these sectors are robotics, artificial intelligence, big data, smart photonics, and Internet of Things. But besides of this catalog, we have the other competences that you might see on this slide. To support our innovation, the Tech for Agro-Food initiative, we have associated 6 laboratories that support this. The most relevant is the Tribelab, that is the laboratory in robotics for IoT, but we have also other laboratories like for optical and electronic technology, laboratories for computer and graphics that is established at Utad, and optical sensors laboratories, and we have also the smart grids and electric vehicles where we can develop the agri-photovoltaics ecosystems. To support this, we are driven of this definition of smart and precision agriculture and forestry, where we aim in this concept of smart and agriculture, smart precision agriculture and forestry, we aim to measure everything that we can on the field, everything, of course, that is relevant for taking the decisions. This can be done with robotics or IoT or remote sensing. These data that are collected on the field are sent afterwards to the decision supports where data analytics and AI can be used to transform this knowledge in prescription map to tell to the robot or machinery where to apply the right product in the right time, on the right amount, and in the right place. To do this, we have this prescription map that will feed the robots or the machinery that will put the things on the field with the accurate manner. This will make the farm more sustainable and we will make more friendly of the environment. Of course, this is aligned also to the new requirements like food security and bioeconomy. We have several European projects that are being on the portfolio of Tech for Agro-Food initiative. One of them is the Demeter, where we had the challenge to create a Portuguese pilot where we tried to create interoperable ecosystem where any data could be transformed from transported between IoT to the decision support system and to the machinery. This is a challenge that keeps still alive, that is nowadays referred and mentioned as data spaces, and these data spaces are now being worked on the Gaia X projects. We had also the experience of AgroFood, that is a digital innovation hub, where we try to support the sector to innovate the sector with more robotics and more artificial intelligence on the system. This project has already finished, but we have nowadays in Portugal another digital innovation hub that we could support companies and the ecosystem to make this system more smart and digital. This is another project that is still alive. That is project we have developed in Novaterra, where we have developed the robot that is capable to maintain and control the weeds in viticulture that is mostly realized in steep slope viticulture. This robot is able to go to these fields and fully autonomous navigate even if the GNSS fails or if the terrain is not flat, if it has some slopes, it can understand where is the best place, but I will speak afterwards about this project. This is another project where we have developed a novel robot, and I will show you afterwards, that was coordinated by Inesc, and this robot is able, this project we have developed a robot that is able to make the spraying more precise and more friendly of the environment. This is another project. We don't do only robotics. We have this smart fertilizer where we were able to put a novel technology inside of the slurry tank, and we were able to measure the quantity of nutrients that are inside of this slurry manure, and using this knowledge we can apply on the field the right quantity of product that is really needed for the terrain. This can be done when a prescription map is sent to the machinery, and the machinery will decide on the terrain where to apply more or less products and make more valuable this product. Not normally are considered a waste of the farmer, and nowadays with this robot we can optimize the use of this subproduct. This is another product that we like too much. That we like very much. That is the Biotech 4, where we use robotics and IoT technology to recover biomass from the forestry and this will help to reduce the fires. I will speak more in the front about this. And so in Hashtag and inside of the Tech for Agro-Food initiative, we have this concept of the triangle, where we consider that Inesc is the company or the institution that is able to realize research in some topics and development in some topics to reach the prototypes till TRL 6 or 7. This is done and driven by the end users, normally the farmers, and we consider always the technology provider, someone that can take these prototypes and put it in the market at the service of the end users. This is our main partnerships in Portugal for the Tech for Agro-Food initiative. And besides of that, we work with this ecosystem, normally with direct contracts, European projects, also FCT projects. So mostly we can go from research projects till innovation projects. And this mostly of the time we are considering master's students and PhD students to support some parts of these developments. These developments normally supports a better PhD and better master students thesis that are more applicable and has a challenge making driven these PhDs and this master thesis. So speaking about the Tribe Laboratory, that bring us to this presentation, the Tribe Laboratory has born in 2014, and this was born from looking to the Portuguese reality, how the agro-food sector is realized in Portugal, looking for the strategic agenda for European robotics and for IoT, looking for the precision and smart agriculture, like I mentioned you before, and also looking for the main trends in big manufacturers of machinery. And in this case, you can see sometimes we have big machinery, seedling, very small parts, and sometimes there are tons of machineries, a machine that weighs tons, planting or seedling grams of seeds. This has two problems: the soil compactation, and if the machinery breaks down, we have a downtime of the machinery that imposes some impacts to the farmer. So taking this into consideration, we aim in terms of R&D be positioned as a reference in researching and developing modular, safe, autonomous, small-size agricultural machine. When we speak about small size, we speak about less than 1 ton that could be applied in 3 main realities that tells a lot about Portugal or are very relevant for Portugal. The permanent woody crops, for instance, where we have the port wine being produced, the protected crops, normally known as greenhouse or controlled environment, or also for robotics for forest biomass collection, this to reduce the impact of fires and make the forest more sustainable. We do robotics, but we also believe in IoT sensors that are relevant for robotics, but also could be used to update old machinery or even to collect data in situ. Of course, this is aligned to the intelligence, robotics and intelligence systems for smart and precision agriculture and forestry. Well, to drive our research and to support our PhD students and master students, we have defined in 2014 a roadmap that has started in 2017 and will finish in 2027. Now we are working in a new roadmap, but just to help you understand what was the last roadmap that was supporting our innovation and our PhD students and our master students, we had these milestones. In the first instance, we had the objective to have robots that were able to go to steep slope viticulture and do monitoring in high and accurate precision manner. On the second milestone, we had the goal to have precision sprayers that are robotics and that reduce the impact of the spraying operation. And we are at this moment working in pruning and harvesting. These two milestones are supporting, or these challenges are supporting several master theses that are running at Inesc. At this moment, we have 4 PhD students working in pruning and harvesting. Well, being said that, uh, as I mentioned to you before, we are a laboratory and we are a multidisciplinary team. So to work on these topics and this challenge, we need to tackle this from several perspectives. And these perspectives, being robotics, means that we have several components that we need to work on. At the moment, we have 6 groups of R&D topics: the safety, mission, supervision, and interoperability topic that is in both sides of robotics and IoT and automation. The outdoor field and navigation, that in this topic we have several channels to tackle, mostly to solve the problem of navigating in places where we don't have GNSS, or even when the terrain is not flat and has some slopes and the robot needs to be aware of their center of gravity. We are working a lot on perception system using AI and deep models to understand the environment, manipulation and grasping, embedded systems and advanced sensors, mechatronics and advanced mechanics. At the moment, we are 13 persons working in this laboratory, and this is our organization. So the PhD and the master's thesis that are developed in this group are supported with a big team that helps to make the PhD work more impactful for the society, but even more impactful for the PhD candidates. Well, to support our technology deployment and validation, sometimes this is very relevant also for our PhD candidates, is to collect real data in real conditions. And to do that, we have at the moment 5 places where we can do these experiments and data collections. One of them is at Quinta do Seixo, Sograb, from Sograb company, but we have also other places like from Ineab, we have from Arboleda, and where we can collect real data. We have also a forestry place from Navigator that we are using to collect real data that can impactful the society. Well, to not take too much time on this experiment, I will show you some of the results of laboratory. And this is the first robotic solutions. This is a robot that is navigating in a steep slope vineyard, moving fully autonomous even if the GNSS fails, with path planning. This has supported 2 PhD candidates at Inesc that they have defended their PhD at 2 years ago at Utad, and this was a prototypes that support this work. This is another technology. This is a forestry robot for biomass collection, and this has also support the PhD work from other PhD student that has defended this PhD thesis at 1 year ago in Utad. Well, and this is another robot, the same robot from forestry that we have applied to precision spraying in vineyards. Well, taking consideration that to put on the market, we need to have technology more prepared for small and medium companies, because they have uh, very limited R&D departments, and so we need we have needed to rethink how we can do robotics. And in this way, at 2 years ago, we had a new start that was defined as building the full robots from scratch. This will help to transfer the technology more easily to the market and support more PhD candidates, not only in software but also in mechanics. And in this context, we have 2 prototypes that we call Vet Robot and Model E, and these robots are presented in this photograph that was taken in the Quinta do Seixo, where you can see the 3 robots that we have built from scratch, and they are fully functional and validated in this context. Of course, this is being evaluated, and nowadays we have also another robot that is the Orius robot that we hope to make this a startup with this robot, and this is a small, very small robot that was built by 10 persons from Inesc, and this is a robot that can go to any field and make an estimation of the productivity map, count the numbers of apples, and this can feed the farmer with this information that might be relevant for planning the future, where to treat each plant, and we hope with this robot to reach a startup company, and this startup company will have a previous PhD candidate at Utad, and nowadays they are trying to make this technology more suitable for the market, and nowadays we are exploring this. This is the Scorpion robot, the Scorpion project, and the previous robot that I have shown to you before was updated to reach this novel robot from this novel robot that is able to go to any steep slope vineyard and make precision spraying with high levels of accuracy, and use not just liquids to spray, but also it can use UV lights for novel treatments in these vineyards. This prototype has supported another PhD work that was already defended with success at 6 months ago, and the colleague that was working on this, it will test and validate several technologies, variable rate technologies for precision spray. As you might see, this is a robot that can operate in offset mode with a recovering panel. This is very relevant for steep slope vineyards because you don't have the terrain from both sides, and is also a very innovative robot compacting best. This is the model here. As you can see, this is a robot that will operate in vineyards for maintain and control the weeds in the vineyards. This is also another robot that will work in this context and control the vegetation growth, and has also supported another PhD thesis on the topic of the basic tools for moving and vegetation growth, the row and row. We hope to take this robot to the market, and this robot is using technology that was developed for other PhD tools, mostly from navigation, path planning, and stuff like. Besides of that, this is the robot. I want to show you this because this is very relevant. In this video, you can see the same robot using AI technology developed by PhD and master students that is able to detect the trunks and make the precision spraying where the precision fertilization when is detected the trunk, and put the fertilizers on the right spot in the right place. This is a machinery operating in very harsh conditions, and normally in this place is not able to pass the tractor, but this robot was able to pass this or through pass this. This is the same robot making precision spray. I mentioned to you before. Here was used also the technology from sprayers. This is the same robot operating in several contexts. It was awarded by the FIRA event, but also you can see here this robot operating in very steep slopes vineyards like this one. So just to support your notion that these robots can operate on this context. We are working nowadays in pruning, harvesting, and let's hope that next year this supports new theses from PhDs, from master students, and we have the goal to reach more innovations. So we do science with impact in the society. So here we can see the landscape of robotics for agriculture, and Inesc was in 2022 listed as one relevant institution for doing robotics. As you might see, so this is supported with PhD students, and this means that we have robots with impact in the society. Besides of that, we have more than 120 publications in in the last 10 years. So we have a good impact on science, but also in the side of innovation. Here I can show you some IoT prototypes that are also supporting innovation in PhD and master students. I will not take too much time on this. This is a smart trap for collecting the detection of bugs that could exist and bring diseases. This is supporting another PhD student. This is the crop sign. This is another component that we have developed at Inesc, and this is supporting several PhD theses from agronomics till electronics. This is another sensor that we have developed for research purposes. I will not detail too much. This is another solution that we have from IoTs, the smart scissors and the smart bucket. This will help in places where we don't have machine or robotics for harvesting to collect to obtain the production map. This is being done with a colleague that is doing the PhD at Utad, and this was also patented, and we are hoping that this patent can bring positive being approved in the coming year, and this is supporting also our PhD students. And this is the result of this use of these scissors. This will help to reach production maps that is very relevant for the viticulturalists. So this is the Pixel robot. This is another tool that is mostly a robot that is used to collect information, to produce digital twins, mostly for collecting intensive data that will support also agronomic PhD students, but also future electronic PhD students that want to work in AI. And so don't taking too much time. In the future, we are working and exploring more the urban farming, agrivoltaics, renewable energies, and experimental facilities for more advanced PhDs in another topics that are more complex. Thanks for listening my presentation, and I hope that if you are doing and expecting to do a PhD thesis, if you don't have where to do this, you can consider our laboratory. You are more than welcome, and I hope that you enjoyed my presentation.